Hey folks, this video is just going to be an introduction of vectors. And vectors often look like something like this that people draw, and you may have seen them before. This video is really going to just be an introduction, okay? It's not going to be getting into how to solve different vector problems, okay? It's just going to explain a little bit about vectors. And then I believe there will be like 7 or 8 videos that will go into different aspects about dealing with vectors. Right now it's just an introduction, so I'm basically going to read through this with you in case you don't like reading. So vectors, besides being a nice sounding word and a popular breakfast cereal here in Canada, vectors are also useful. They help us visualize a real life situation involving one or more forces. For example, police have to deal with vectors when they're dealing with a car crash and they're trying to figure which car is at fault. Okay? So vectors do these kinds of things. They predict the outcome when two objects collide with each other. Sometimes when cars crash, someone lies about it and says, they hit me. And really, when they do their work and they deal with vectors and they deal with the forces that are involved, they realize that one person is actually lying instead of telling the truth. So that's where vectors come into play. The other thing is vectors will help you figure out the speed and direction of a boat or an airplane that's moving on water or through the air. So an airplane, for example, is, airplanes are getting hit by crosswinds. When I'm flying between Toronto and Calgary, for example, I noticed that it's actually quicker to go from, I believe, Calgary to Toronto. And I'm not sure if that has something to do with crosswinds or winds that are happening up in the sky. But anyway, vectors can help us with stuff like that too. People that do engineering and yeah, those kinds of folks, they deal with vectors all the time. Okay, here are some words that you'll need to know when dealing with vectors. We can circle them. A vector is a quantity that has both magnitude and direction. So magnitude and direction. It's two things. Your teacher may give you a quiz and it might just have a direction on it, or it might just have a magnitude. And if it just has one of these two things, then it's not a vector. So a car traveling 80 kilometers per hour north could be a vector. But if they just said a car is traveling 80 kilometers per hour and they didn't say what direction, that is not enough information for us to draw that out using an arrow. If it was traveling 80 kilometers per hour north, we could draw that and say that's 80 kilometers per hour. And then it has to be in the direction, and we usually call this direction north when we're heading straight up on a page. Okay? Or a car parked 50 kilometers southeast of Peterborough. Well, that's just that offers a magnitude, how far away, and a direction, southeast. Okay? A scalar is just a number. So we've talked about a vector. We've talked about magnitude and direction. And over here we're going to talk about a scalar. A scalar is just a number that describes the magnitude. For example, time, temperature, mass, speed, distance, or volume. That is a scalar. 90 kilometers per hour is just a scalar. There is no direction given. Okay? So this is the scalar. And the direction, of course, is the direction, the north part. The scalar would be like that, 80 right there. Okay? Weight is a vector. Here's a note. Weight is a vector only because our weight actually has a direction. Normally weight would not be a vector, but it is because weight has to do with gravity acting on us or acting on the object. Okay? So there's a force downwards towards the earth on an object due to gravity. Okay? The last thing on this page is something called newtons. Newtons are symbolized by the capital N, and they are the metric unit used for force. So weight could be characterized as Bob has a weight of 800 newtons downwards. Okay? You will see N, or newtons, used often when talking about vectors and force. Okay? So now we know that vectors will always give some magnitude and also a direction. The way we represent vectors on paper is just by drawing an arrow kind of like this. The length of the arrow and the direction that it's going are how we represent a vector. It looks like this, okay? So the arrowhead is this part, okay? The arrowhead is here, okay? And the other end is called the tail, okay? So heads and tails. All right. This vector is labeled as vector v, and it can be shown using a little arrow up above. So you can say this is vector v with a little arrow like that. Okay. The other way you could call this is vector ab, and it has to be vector ab. It can't be vector ba. It can't be vector BA because it's not traveling from B to A. That vector is going from tail to head or from A to B. So you have to write it this way here. Okay? Is that it for that page? Yes, it is. The longer your vector, the more magnitude it has. A car driving 20 kilometers per hour, let's say it's driving 20 kilometers per hour east. Okay, 20 kilometers per hour east. That is going to have a vector that's twice as long as a car only going 10 kilometers per hour. Okay, so this vector here would be 10 kilometers per hour. Also going east, it's going in the same direction, but it would be half as long as this. Okay. Vectors, let's see, magnitude is always positive. It can never be negative. You can't say you're going negative 20 kilometers per hour. That's just something we don't do, okay? Two vertical lines that look like the following, like this, they can indicate the magnitude of a vector. When you put something between these two lines, in math they call that the absolute value. In other words, it's a value that is always positive, okay? There can be no negative numbers that come out of these lines, okay? There's no such thing as negative 20 kilometers per hour, okay? So there's some terminology about vectors, and there's just some basics about what a vector looks like. We're going to do a lot more with vectors, but we're going to save that for other videos so that it's done in smaller chunks and you don't have to watch one super long video and try to remember it all. Okay? I believe that's the end of this video. Take care.